A 4 ohm resistor and a 6 ohm resistor are connected in series. A third resistor is connected in parallel with the 6 ohm resistor. The whole arrangement has an equivalent resistance of 7. What is the value of the third resistor? Okay, so the idea here is, well, first thing we do is we draw things. So we have a resistor. This will be the first resistor. This will be the 4 ohm hook. And it's connected in series with a 6 ohm. And so when something is connected in series, that means that the output of the first resistor, let's say this one, will be the input of the second resistor. Output connected to input. A third resistor is connected in parallel with a 6 ohm resistor. So when things are connected in parallel, that means that they share the input. Instead of the output being the input, they have a shared input. And so this will be our mystery resistor. I'll call this R3. And we know that this has an equivalent resistance of, I'm not going to draw them connected like that. There we go. This has a combined resistance, I'm going to call it total of, let's see, it says 7? I think it said 7. 7 ohms. Okay, so the way you combine resistors in series, you have R series equals R1 plus R2. And then R parallel, 1 over R parallel equals 1 over R1 plus 1 over R2. You add the reciprocals. And so what we're going to do is we're going to use this concept to analyze this circuit. So we're going to have, I'm going to call this part right here, these two in parallel, I'm going to call this R equivalent. With R equivalent, this is going to be this one and this one in parallel. So that R total is, let's see here. Back to the pen. Ooh, purple. R total, which we know equals 7, is going to be 4 plus, and then I'm going to call this R equivalent, which equals 7. So we can solve this part right now. I'm going to wait a little bit, but we know that then this R equivalent then will be a total of 3. Okay, so now we're going to look at R equivalent. So R equivalent, I guess 1 over the reciprocal, will be, I'm going to call this R1, I'm going to call this one R, nope, I guess I'm going to do this one, call this one R2, call this one R3. I know, excessively confusing, unnecessary confusion, and for that I'm sorry. Plus 1 over R3, rearranging 1 over R equivalent minus 1 over R2, which is the known one, equals 1 over R3. R3 is the unknown. We're going to do a common denominator between these two, so we have R2 over R equivalent R2 minus R equivalent over R equivalent R2. I know, messy. And then that'll still equal 1 over R3. Combining, we have R2 minus R equivalent over R equivalent minus R2 equals 1 over R3. This is supposed to be multiplication down here. Yes. Okay, now flipping everything over and changing colors. We have, I'm going to also switch sides too. So R3 equals R equivalent times R2 over R2 minus R equivalent. This is just math, just algebra. No big deal. So we're going to solve for R equivalent. We're going to use this part right here. So R equivalent equals 3. This will be ohms. And so we know that R2, I think it was 6. So I'm going to put this down here. So we have 3 times 6 all over 6 minus 3, which is 18 over 3, which is 6. So we have 6 ohms. Let's go plug this back in real quick and check to see if this makes sense. So according to the math, that right there, 6 ohms. So one quick rule of thumb you can do with resistors in parallel, if you have 2 resistors in parallel that have the same resistance, their equivalent resistance will just be 1/2. You can see that from the formula of multiplying reciprocals and taking the reciprocal. You can go through that on your own if you want, but you're better off just trusting me on this one. So if we have 6 here and 6 there, then the equivalent resistance will be 3. 3 plus 4 is 7, and that makes sense that the total equivalent resistance is 7. So that's how I would approach this problem. Hope that helped. Really the hardest part is just getting the drawing. After that, you can kind of fumble your way through the math. So not too bad. Hope that helped. See you next time.